On June 28, 1947, General Motors introduced the Chevrolet Advanced Design and GMC New Design trucks. The launch brought many new features and a dramatic profile change. For the first time, the headlights fit flush in the front fenders for a sleeker, more modern look. The cabs expanded for more cabin room and a better view. Stylized dashboards with bolder instrumentation grabbed attention while running boards still reached forward to the front fenders. The chassis were well constructed with a beefier ladder frame and proven semi-elliptic springs front and rear. All 1947 to 55 First Series trucks featured traditional beam front axles with kingpin steering knuckles. Advanced Design and New Design half-ton trucks kept the torque tube rear axle with one exception, the 1955 First Series Chevrolet 3100. Beyond Chevrolet cars and light trucks, the only other GM line that used a torque tube rear axle in the 1947 to 54 era was Buick. Until 1954, Chevrolet's Advanced Design trucks kept the 216 Stovebolt inline six, an engine first used in 1937 cars and trucks. The low-pressure dip and splash oiling system for the Babbitt bearing connecting rods was another holdout for Chevrolet. In the post-war era, no other GM division used this approach. During the 40s, none of the industry's truck producers moved much beyond pre-war engine designs. Horsepower ratings didn't matter, and performance expectations were not an issue until the next generation trucks in the mid-50s. The three-speed transmission designs changed very little. The big breakthrough for 1947 Chevrolet and GMC trucks was the rugged, iron-case Muncie SM420 4-speed transmission option. This new 4-speed with a compound first gear and synchromesh on second, third, and fourth gears replaced a non-synchromesh 4-speed box with straight-cut gears. Some refer to the earlier 4-speed as a crash box. They are actually designed for double clutching. The driver's skill acts as a synchronizer to avoid gear clash. Through 1967 in civilian light and medium-duty truck and school bus applications, the Muncie SM420 survived behind inline sixes, higher torque Chevrolet, Pontiac, Buick, and Oldsmobile V8 truck engines, plus GMC's 305 and 351 V6s. The Muncie SM420 transmission handled hefty loads and was still manufactured as late as the 1980s for military vehicles. Before we strip down a 1947 to 55 First Series truck for a restomod build, let's become familiar with the stock Advanced Design and New Design trucks. Knowing more about these models is beneficial to any builder, especially restorers wanting to maintain the full value of their stock truck. After you get to know these trucks better, I'll dive into common restomod builds. First, we'll detail authentic restoration concerns. Then we can move to modifying these classic trucks. Some builders strive for a pristine restoration that will drive up the truck's collectible value. Other builders want milder changes for improving drivability and safety without altering the truck's original profile. Beyond this are the mildly to wildly modified and customized restomod builds. Starting with a stock original truck, the 1947 to 53 Advanced Design Chevrolet and New Design GMC models make desirable collectibles and are fun to restore. These trucks are from another era, and if you intend to drive and service a truck, there is room for improvement. Chevrolet's 1954 update to the 235 Thriftmaster Inline 6 was a milestone. The 1954 235 engine features a full-pressure lubrication system, which GMC's Jimmy Inline 6s had offered since 1939. A one-piece windshield and the engine upgrade distinguished the 1954 and 1955 First Series Advanced Design trucks. In stock restored form, these two model years deliver better highway performance. When 1954 light-duty trucks introduced the full-pressure lubrication 235 Inline 6, Chevrolet's medium-duty trucks got a larger bore 261 cubic inch version of that engine. When restorers want that 3/16 of an inch larger bore, however, this requires a 261 block casting with Siamese cylinders. Siamese means there is no water jacket between the cylinders, and the 261 block uses added steam holes here. The 261 has a different cylinder head to match the steam holes, and uses a different head gasket than the 235. Some modify a 235 head to match the 261 head gasket and steam holes. I believe you are better off finding a matched, original 261 hidden block. This heavier-duty 261 engine has some versions with a full-flow oil filtration system. The 235 engine uses a traditional and outdated bypass oil filter through 1962. Full-flow filtration provides superior bearing protection. The 1955 Chevrolet First Series half-ton trucks came with the first open rear drive shaft, Hotchkiss-style rear axle in a half-ton GM truck. 1955 First Series GMC half-ton models kept the old-school torque tube rear axle with an enclosed drive shaft. If you're planning to authentically restore a 1947 to 1954 Chevrolet 3100 half-ton, or a 1947 to 1955 First Series GMC 100 truck, expect to rebuild the torque tube axle assembly with new seals, bushings, bearings, and joints. From a service standpoint, removing the transmission for overhaul or replacing the clutch gets more involved with the torque tube rear axle. Service is much easier with an open drive shaft and Hotchkiss-style rear axle, like the 55 First Series Chevrolet 3100. I serviced a military surplus truck fleet with several 1955 to 59 Task Force Series 3100 half-ton pickups and a 1960 C10 Apache. The military saw them as standardized equipment, and they were each stone stock. These short wheelbase Chevrolet step-side pickups had the workhorse 235 Thriftmaster engine. I got plenty of experience with this overhead valve Chevrolet inline 6. Compared to advanced design models, the Task Force and Blue Chip engine bays had wider front fender spacing and roomier inner fender aprons designed for the V8 engine options. The fleet also had a medium-duty 1949 GMC new design stake bed truck with essentially the same engine bay as the pickups. All of the inline Chevrolet 216 and 235 engines and the GMC 228, 248, 270, and 302 inline 6s are easy to work on in their engine bays. Laying over the fenders of these utility trucks, I found this especially true for tune-ups, carburetor overhauls, valve adjustment, and fuel pump or water pump replacement. When comparing a 1947 to 53 Chevrolet advanced design truck to a new design GMC, Chevrolet's traditional Stovebolt 216 with its dip and splash oiling system and poured Babbitt connecting rod bearings stands out. While GMC engines went to full-pressure crankshaft lubrication in 1939, Chevrolet was the last GM division to use a low-pressure lubrication system with splash oil Babbitt bearing connecting rods. Keeping up with faster cars on the new freeway systems was not a concern. These were low-geared work trucks often found at construction sites during the post-war housing boom. Buying a light truck for multi-purpose use or strictly recreation was years away. There is an earlier 235 inline 6 with a dip and splash low-pressure lubrication system used in the heavier-duty Chevrolet trucks as far back as 1941. Through 1952, passenger cars equipped with a 2-speed Powerglide automatic transmission used this engine with quieter hydraulic valve lifters. In 1953, the Powerglide-equipped cars and first Corvette Blue Flame or Special 235s stepped up to a full-pressure oiling system. The crankshaft was drilled to lubricate insert-type main and connecting rod bearings. A higher-pressure oil pump looped the lower and upper engine. Despite these gains, Chevrolet light trucks did not get a 235 engine until 1954. If you are restoring an advanced design truck, be aware that engines get swapped around. Know the difference between a 1953 full-pressure engine and the dip and splash 235s or 216s. The 1953 full-pressure 235 cylinder head uses 2 topside acorn nuts for holding down the valve cover. At first glance, this looks like a 216 or a dip and splash 235, which can be confusing. Again, only the Powerglide-equipped cars and Corvette got full-pressure lubrication in 1953. A clear difference in the dip and splash oiling 216 engines is a lifter and pushrod side cover that reaches from above the crankcase to above the spark plugs. Spark plugs on these 216 truck engines fit through the side cover. By 1954, the Corvette, all passenger cars, and the light trucks use a 235 inline 6 with full-pressure lubrication and the familiar 4 hold-down screws at the base of the valve cover. The 4-screw valve cover fits all 1954 to 62 235 inline 6-cylinder engines. This is easy to spot. The 1954-62 cylinder head will not mount on a 1941-53 dip and splash 216 or 235 short block or lower engine. If in doubt, dig deeper to determine whether the engine has an original equipment full pressure oiling system, a drilled crankshaft, and insert rod and main bearings. I can share tips. Post your question as a comment. I'll respond. For anyone restoring a 1947-53 advanced design truck for use as a daily driver, consider upgrading to the 1954-62 235 or 261 truck engine with full pressure lubrication. This modest engine swap will provide more stamina at sustained highway speeds. An original 1954-62 lighter medium-duty truck engine has a solid mechanical lifter camshaft that requires routine valve adjustment. Most 1954-62 passenger car 235 engines use hydraulic lifters. All passenger cars with an automatic transmission got hydraulic lifters. The few exceptions are the manual transmission-equipped cars in 1954 and 1955. They got a solid lifter camshaft. From 1956 to 62, all passenger car 235-6s have hydraulic lifters. If you do this swap on an otherwise stock restoration project, keep the original 216 Stovebolt 6 to retain the truck's resale value. Worth mentioning, the 1954-62 261 truck camshaft has a higher valve lift and was the pick for the Corvette Blue Flame Inline 6. This is a solid lifter camshaft that worked well with the Corvette's triple side draft Carter one-barrel carburetors. Consider the 261 camshaft a mild hop-up grind for a full-pressure lubrication 1954-62 235 truck engine. More valve lift with a milder valve opening duration creates strong low and mid-range torque, in addition to good manifold vacuum. The Corvette 235 had 8-to-1 compression, a level that advanced design truck engines can tolerate with quality fuel. By the end of the 235 era, passenger car and light truck engines were 8.25-to-1 compression. This coincided with a steady boost in octane from increased tetraethyl lead in U.S. fuel. At the Gardnerville Hancock station in 1963, we pumped 94-octane regular and called high-test pump gas ethyl, essentially today's premium fuel. In 1963, it rated 101 research octane number, or RON. There was plenty of lead in all pump gas. On today's unleaded fuels, I'd target 8-to-1 compression, 8.25-to-1 maximum if you plan to run regular. By 1956, all Chevrolet passenger car 235s had hydraulic lifters for quieter operation. This standardized production and also reduced maintenance and service intervals. If you suspect that a 1954 or first series 1955 advanced design truck's 235-6 has been replaced, rebuilt, or swapped, do your homework. Know which camshaft and lifters are fitted to any 235 engine. Full pressure lubricated 235s have been swapped into many 1947-53 advanced design light trucks in place of the original 216. If you need more insight, I can share a quick test for the lifter type on these engines. As I mentioned, all GMC new design trucks had inline 6 engines with full pressure lubrication and insert shell type connecting rod and main bearings. The truck fleet I serviced included a 1949 GMC 350 stake bed with a 270 engine. I did an in-chassis engine overhaul that gave me insight into the rugged GMC 228, 236, 248, 270, and 302 overhead valve inline 6s. These were commercial-grade engines with stouter oil-pressurized crankshafts and insert bearings. Castings are robust. There is a design and build quality that promises reliability. GMC buffs are quick to boast about the superiority of these Jimmy 6-cylinder engines, and rightfully so. In my view, whether the aim is a stock build, a quality restoration, or creating a pristine and numbers-matching original collectible truck, understanding the difference between an advanced design and a new design truck begins with a better understanding of GMC models. Generally considered a stouter light truck, GMC original equipment explains why owners have bragging rights. Styling-wise, while the cab and chassis are essentially the same as a Chevrolet advanced design truck, the grille, dashboard, and instrumentation are unique. GMC's new design trucks offer their own, more robust engines. Short of a restomod build, a new design pickup can easily be upgraded with a 270 or 302 GMC Jimmy inline 6. This subtle engine change is nearly undetectable, though in the same family as the 228 and 248, the 270 and 302 inline 6s are stronger performers that originated in medium and heavy-duty trucks. Performance-wise, this is like replacing a 216 with a 235 or 261 inline 6, or a 265 or 283 Chevrolet V8 with a 327 or 350 V8. In addition to the 3-speed and manual SM420 4-speed choices, GMC also offered a rugged 4-speed, dual-range Hydra-Matic automatic transmission option from 1953 up. The options list for the 1954 and First Series 55 Chevrolet trucks did include the Hydra-Matic, although the Hydra-Matic is seldom seen and is rare enough to be a prized collectible. The Hydra-Matic was available in GMC 100 series half-tons through heavier-duty GMC trucks, including the military 6x6s. This hefty, band-type iron-case transmission is famous for its stamina in GM luxury cars, trucks, and vintage hot rod retrofits. The first gear ratio is either 3.82 to 1 or 409 to 1, depending upon the model year Hydra-Matic. This is substantially low for planetary gearing. The engine mates to the transmission through a fluid coupler and not a torque converter, so there is no additional reduction ratio. The original Hydra-Matic was the foundation for the legendary B&M Hydro-Stick transmission. Dual-range Hydra-Matic transmissions are a beast. A dual-range Hydra-Matic equipped truck could be a pick for those wanting a durable, original equipment automatic transmission. If original equipment, and if your goal is a stone stock restoration, the dual-range Hydra-Matic enhances the truck's collectible value. If not original equipment on the truck, finding parts for a dual-range Hydra-Matic would be a wild card. GMC light and medium-duty civilian trucks only use this transmission through 1962. The last iron case, dual-range Hydra-Matic was fitted into Rolls-Royce limousines under a license agreement in 1978. Clifford Performance targeted the Jimmy 6s for racing builds. When Jack Clifford founded his company in 1967, the motto was 6 equals 8. Jack combined his engineering prowess with racing experience that earned NHRA records. He made history drag racing with well-tuned Hudson inline 6s. I interviewed Jack for Off-Road Magazine in the 80s. We shared a common interest in inline 6-cylinder engines. He gave me copies of his recommendations for both Chevrolet and GMC 4 main bearing 6 build-ups. I have kept that data in my library for nearly 40 years now. While a 3 versus 4-speed transmission may seem a small matter, it isn't. My work life has included rebuilding both manual and automatic transmissions. 3-speed transmissions with synchromesh on second and third gear only were used in Advanced Design, New Design, Task Force, and the first Chevrolet CK trucks. Lacking synchromesh on first gear is a limitation and requires driver awareness. These are not bad transmissions in any sense. In fact, the patented synchronizer clutch and cones design is innovative and stout. Be aware, though, that a higher mileage 3-speed will always require a rebuild to make it last. At the very least, the bearings and synchronizers wear. Loose bearings create gear mesh issues, which accelerates gear tooth wear. If you're concerned about pulling power and a wider range of gear ratios in a period-correct stock transmission, the Muncie SM420 4-speed will go the distance. Under most driving conditions, this floor-shift transmission with synchromesh on second, third, and fourth gear enables second gear starts. The compound low first gear is for moving heavy loads at crawl speeds. The SM420 option began with the Advanced Design and New Design 1947 models. By the 1960 CK era, nearly all 4x4K trucks and many two-wheel drive C models had the SM420. The most common version of the SM420 has a non-synchromesh compound low gear ratio of 7.05 to 1, making it the time-honored conversion transmission for 4x4 Jeep CJs, the early Scout, Land Cruiser FJ40s, and other 4x4 applications needing a low crawl ratio. As a light and medium-duty truck offering, the SM420 4-speed transmission served well through 1967, behind inline Chevy 6s, the high-torque GMC V6s, and robust V8 engines. In good condition or rebuilt, an SM420 can handle considerable power. Gearing this low enables lower output dip and splash 216 or 235 engines to get the job done. Though weighty due to gear and shaft sizes, the iron case SM420 is relatively short. This has made it an optimal conversion transmission for shorter wheelbase vehicles like the vintage Jeep CJs, early Scout, or FJ40 Land Cruiser. Chevrolet and GMC half-ton advanced design and new design versions of the SM420 have an output for the torque tube rear axle if the truck is so equipped. The 1955 First Series Chevrolet SM420 4-speed has an open drive shaft output yoke. If you're building a restomod and know for sure that you'll never need the Muncie SM420 again, it will fetch an instant sale to a vintage off-road 4x4 builder. The 705-to-1 compound low gear plus a transfer case low range are perfect for crawling rocky trails. The 216 and early 235 engines with low pressure lubrication and dip and splash rod oiling can suffer low-end failures due to sustained higher speed operation. Heat is just too much for connecting rod poured Babbitt bearings fed by oil dippers. Buick had an oil cooler on its Babbitt rod bearing straight 8 engines through 1948 and had higher full-pressure lubrication at the crankshaft. Unlike the dip and splash Chevrolet 6s, pre-1949 straight 8 Buick engines can be easily converted to 1949 up insert bearing connecting rods because the crankshaft is drilled for pressure lubrication at the rods. The dip and splash 216 and 235 engines have no oil passages in the crankshaft to lubricate the rod bearings. For a collectible or pristine truck restoration, unless driven on the highway a lot, I'd simply do a blueprint rebuild of the stock 216 and restore the dip and splash oiling system, poured Babbitt rod bearings, and the original crankshaft. For an advanced design Chevrolet 3100 restoration project intended for street and highway driving, an optimal start would be a 1955 First Series 3100 equipped with the optional Muncie SM420 4-speed transmission. For a stock or near-stock restoration, I single out the 1955 First Series model for its better performance in stock form and the subtle upgrades found in this final advanced design truck. I want to drive a vehicle after restoring it. As a stone stock restoration, the 55 First Series Chevrolet 3100 has the updated 235 engine, subtle chassis improvements like the tubular shock absorbers introduced in 1950, the first Hotchkiss open driveline rear axle in a Chevrolet half-ton truck, the 1954 one-piece windshield update plus styling, trim, dashboard instrumentation, and gauge clusters that draw from the mid-50s cars. This First Series pickup, once restored to as new condition, could handle moderate highway speeds without working itself to death. Another pick for a stone stock advanced design Chevy pickup restoration project would be the 54 3100 with its one-piece windshield and updated full-pressure lubricated 235 engine. You can live with the torque tube rear axle, as many builders and owners do. There is good reason for interest in any 1947 to First Series 1955 Chevrolet or GMC truck. These trucks are all worth restoring. There are no bad models. Parts are readily available in the aftermarket. All 1947 to First Series 1955 Chevrolet and GMC trucks have 6-volt electrics that can be easily upgraded to 12 volts if desired, without detracting from originality. As a light and medium-duty truck fleet mechanic, I gained considerable experience with the 1954 to 62 Chevrolet 235 and 261 inline sixes. Although these are robust engines for the period, the crankshaft is only supported by 4 main bearings. This design is also common to inline GMC light-duty sixes through 1959, Toyota Land Cruiser F-Series engines, and many other pre-60s inline 6-cylinder car and light truck engines. While 4 main bearing inline sixes are not as durable as the 7 main bearing inline 6, the crankshaft rod pin locations and cylinder firing degrees make any inline 6 inherently balanced at critical harmonic levels. Aside from overall smoothness of inline 6s, this makes chores like carburetor idle mixture and valve clearance adjustments easy. When identifying a 1954 to 62 Chevrolet original equipment 235 or 261 inline 6-cylinder truck engine, You will find adjustable solid valve lifters, an oil bath air filter, and a dash-controlled, cable-actuated manual choke on the carburetor. Short of an all-out restomod, many builders simply want modern power in their advanced design or new design truck. Most engine swap upgrades turn to V8s. The small block Chevy has been time-honored. For a moderate, modern boost in power, I would go with a 1963 or newer 7-main bearing Turbo-Thrift 6. A 7-main bearing 230, 250, or 292 Chevy inline 6 swap, if done right, contributes to a retro look. This approach only works for inline 6-cylinder enthusiasts, and I count myself among them. When the scale tips toward building an all-out restomod or a high-performance street truck, V8 options, along with major suspension, drive axle, and steering system upgrades, dominate the scene. The Turbo-Thrift inline 6-cylinder family launched with the 1962 Chevy 2 Economy car's 194 cubic inch inline 6. For 1963 CK trucks, a similar 230 Turbo-Thrift 6 became the base engine, and a tall block deck 292 cubic inch option came online. In 1966, a 250 cubic inch Turbo-Thrift variant boosted the base engine power. Turbo-Thrift engines reach their torque peak at a lower speed, typically 1600 RPM. We call this a quick torque rise, and 1600 RPM rivals a light-duty diesel's torque curve. The same torque rise and torque peak RPM as my 2005 Ram Cummins 5.9 diesel in stock tune. Of course, the stock 5.9-liter HO Cummins produces a substantial 610 pound-feet of torque at that RPM, depending upon their tune, the truck application, and emissions constraints. Turbo-Thrift gasoline 6s peak their horsepower in the 3600 to 4200 RPM range. The Turbo-Thrift 7-main bearing inline 6s build horsepower steadily from their low torque peak RPM upward. The performance advantage is the quick torque rise. Turbo-Thrift assets include the 7-main bearings, lighter iron castings, and a lighter valve train. Designed to share numerous parts with a 283 small block V8, Turbo-Thrift inline 6s have stamped rocker arms, rocker studs, and ball pivots, instead of a rocker shaft with iron arms like the 235 and 261. All Turbo-Thrift engines use hydraulic valve lifters, a first for Chevy's truck inline 6s. Turbo-Thrift inline 6s use a standardized Chevrolet small or big block V8 bell housing pattern and a common crankshaft flywheel bolt circle. From 1963 to the mid-80s, this is a rock-solid truck offering. The tall block deck 292 inline 6 variant is a stump puller, with bottom-end torque that rivals the 60s GMC 305 V6. Historically, the only complaint about the long-stroke 292 is poor fuel efficiency at sustained highway speeds. This is a workhorse engine most often found in commercial light and medium-duty trucks and vans. Before restomod builders roll their eyes around my inline 6-cylinder support, let's consider the build potential of the 292 inline 6. Here's a Summit Racing example of an all-out build. Building inline 6s is a niche that many classic truck and car enthusiasts enjoy. I've done my share of 6-cylinder work and knew Jack Clifford, founder of Clifford Performance, from my 1980s and 90s off-road magazine days. For 4x4 Jeep magazine and book projects, I built AMC Jeep 258 and 4-liter inline 6 engines, including the Mopar Jeep era 1991 up 4-liter inline 6s with a retrofit 258 crankshaft. For 30,000's oversized, this makes the popular 4.6-liter stroker motor. I worked with Mopar staffers who were early builders of the 4.6-liter stroker motor. These are 7-main bearing engines with a proven track record for rugged use and longevity. The 250 or 292 GM Turbo-Thrift engine is equally impressive. I would not rule out the 230, although it just makes sense to power up with the larger displacement engines if available. If fuel mileage is a goal, the 250 has it. For brute low-end torque, nothing beats a 292. For a more period look, the new design GMC 4-main bearing 248, 270, or 302 inline 6s have been long-standing replacements for the advanced design Chevrolet 216 truck engine. Be aware that GMC engines are slightly longer than a Stovebolt 216. Similarly, late 235 water pumps can have a longer nose when replacing a 216. For swapping these engines into a 216 Chevrolet Advanced Design truck, either issue needs a remedy. This involves properly mounting a GMC 6 or later 235 at the front crossmember and making sure the engine allows enough fan clearance at the radiator. There is an aftermarket short-nose water pump available for the 235. These concerns apply to any inline 6 or V8 engine swap. When listeners and viewers run into issues, I cover solutions at the podcasts. Please subscribe and post your comments. We've all seen or performed V8 conversions. They are somewhat more difficult to accomplish in the narrow Advanced Design and New Design engine bays. I've done Chevy V8s into FJ40 Land Cruisers for magazine and book projects. The FJ40 was designed for an inline 6 that's a virtual knockoff of the Chevy 235 or a similar GMC 4-main bearing engine. The issues of steering gear and steering shaft retrofits, front axle clearance, plus motor mount fabrication are much the same. Since V8 swaps are common for restomod trucks, we dive into V8 conversions at the podcast. There are frames, steering system, and sometimes front suspension modifications necessary for a V8 swap. By comparison, a lighter weight Turbo-Thrift inline 6 can fit with the least amount of fabrication work. Like the other inline 6 swaps, make sure the fan and radiator clear properly. If the stock steering system is acceptable, the inline 6 allows ample room for the original steering gear and column. Whether it makes sense to keep the original Advanced Design or New Design worm and roller steering gear is certainly debatable. I devote podcast time to safer steering upgrades that work well. Despite my wholehearted appreciation for classic GMC Jimmy inline 6s, if highway cruising, safely merging onto freeways, and daily driving are your goals, I would opt for a Turbo-Thrift 7-main bearing inline overhead valve 6, or possibly a small block Chevy V8. Unlike the vintage Chevy 235 and 261 or the GMC 248, 270, and 302 inline 6s, the Turbo-Thrift and small block Chevy V8 can sustain modern high-speed roads. For mild restomod builds, this invites a wide variety of bell housing and transmission options. The 292-6 has considerable bottom-end torque, and like a V8, the 292 works well with tall axle gearing for highway use. A 292 outperforms a vintage 302 Jimmy for power and low-end torque, especially with the many aftermarket performance upgrades available for Turbo-Thrift 6s. A key reason for my promoting and dwelling on the inline 6-cylinder option is to preserve the chassis and engine bay. This is important for restorers wanting a moderate performance upgrade. Done thoughtfully, there is minimal effect on the Advanced Design or New Design frame or engine bay sheet metal, plus a more authentic period look than a V8 swap. Beyond that, most automotive machinists who could readily jump into rebuilding a vintage 4-main bearing engine have now retired. True, there are specialty shops that perform this work. However, in my experience, the longer stroke vintage 6s with post-war GM block metallurgy are prime candidates for cylinder taper wear. Combine a relatively low nickel content, common gray cast iron block, iron piston rings, and lower axle gearing, higher numerically, with more piston travel per mile, and these engines wind up with extreme cylinder wear. Whether or not previously rebored, boring vintage blocks more than 40 thousandths of an inch over stock increases the risk of engine overheating. If boring 60 thousandths or 80 thousandths looks necessary, sonic test the cylinder walls for integrity and their thickness before boring. Sleeving or finding another block may be necessary. I've worked with higher mileage 50s 235 Chevrolet 6s that required a 60 thousandths of an inch rebore on the engine's first rebuild. This was due to severe cylinder taper, which again could be attributed to low nickel content in the cast gray iron block, the cast iron rings, plus a long piston stroke, lower axle gearing, which is numerically higher, and more piston travel per mile. Add to this the use of old mono-weight paraffin motor oils without modern dispersant or detergent additives. Then there's the bypass oil filtration system instead of full-flow filtration. In 1963, 14 years old and working my first summer gas station job, I filled and stacked glass oil bottles with reclaimed motor oil for customers with older engines and pocket change budgets. That kind of oil went into aging 216 and 235 inline sixes and showed up in machine shop and recycling yard cores. The result is high cylinder taper wear. As a footnote, there's controversy about nickel content in blocks. I have considerable experience with the Toyota F and 2F inline sixes, largely patterned after vintage post-war GMC 4-main bearing inline sixes. When pulling down a 2F engine from my 76 FJ40 Land Cruiser, the cylinder still had faint crosshatch honing to the top of the piston ring travel. The block showed the slightest amount of wear or cylinder taper. However, handling the worn, razor-sharp-edged piston rings lacerated my fingers. This was clearly a much harder, wear-resistant iron block casting, which contributed to Toyota's legendary 300,000-mile engine survival, commonly proven with the 20R and 22R mini pickup engines. There was something in these castings, though research suggests this was just well-refined, high-carbon gray iron and better foundry methods. Nickel has clearly been an asset in iron cast blocks, though the levels and specific engine applications are nebulous. For post-war U.S. industry and GM production standards, any distinct use of higher-level nickel and tin in passenger car or light truck blocks is not clear until at least the 1970s Endure castings. Toyota, having refined smelters, casting methods, and heat treating, would not be surprising. The Land Cruiser is proof enough. Despite my enthusiasm for retrofitting a Turbo-Thrift engine, this is still a swap. They don't just bolt in. For a near-stock classic truck build, the upside is that you would have less complicated motor mounting issues and no major engine bay, steering gear, or frame clearance troubles, like with most V8 swaps into an advanced design or new design chassis. Done right, the truck could easily be returned to its pure stock state after installing an inline 230, 250, or 292.6. Unless you need or want exceptional power, these Turbo-Thrift 6s are a milder, less complicated engine swap, an option to consider for a near-stock restoration project and truck intended for driving.
In the podcast, we'll dive much deeper into powertrain, axle, and other updates on the advanced design and new design Chevrolet and GMC trucks. In the next podcast, we'll move from mild to wild with the restomods. Following the time spent at hot August nights, it's clear how hot can get. Please subscribe and join us on the next episode.